Hello class, today I'm your workout trainer and I'm going to teach you about work, power, and energy. My name is Shah and we will be covering the work, power, and energy unit. The topics we're covering today are work, kinetic energy, potential energy, thermal energy, conservation of energy, and power. Let's start with work. Work is the process of moving an object by an external force. It's a scalar unit and is represented by 1 joule. Energy transfers from one object to another when one object does work on another object. The equation for work is W equals Fd, or work equals force times displacement. Work on an object must have a force causing displacement. A force put upon an object doesn't necessarily mean that work is being done. If the object is not moving, no work is happening, because force times their displacement equals 0 joules. Here's an example of work being done on a lawnmower. In this scenario, the man is applying a force of 60 newtons on a lawnmower at a constant velocity across 5 meters of grass. 60 newtons times 5 meters equals 300 joules of work. Energy is a capacity or ability to do work. This means energy has a capacity or ability to move an object. Like I said earlier, energy is transferred from one object to another, utilizing work. Just as the unit joule is used to express work, energy also uses the unit joule. There are many different types of energies, which include kinetic energy, potential energy, and thermal energy. The first type of energy we'll be talking about is kinetic energy, or the type of energy exerted on an object in any motion. The unit for kinetic energy is a joule, as it is a form of energy. The formula for kinetic energy is Ke equals 0.5 mv to the power of 2, or kinetic energy equals 0.5 times mass times velocity squared. Kinetic energy may be translational if the motion of the object is moving along a path, or rotational if the object is moving around an axis. Kinetic energy is also inversely proportional to potential energy, meaning when kinetic energy increases, potential energy decreases, and vice versa.
The next type of energy is potential energy, or the stored energy of an object. While potential energy might seem like a counterbalance to the existence of kinetic energy, it does have one unique property that sets it apart. This property is the fact that not only can potential energy be converted into kinetic, but also into energies such as thermal energy. Also, gravity and elastic forces have the ability to store potential energy, hence the title gravitational potential energy or elastic potential energy. When potential energy is stored in the form of gravity, the energy is greater the higher up the object is. The formula for potential energy is PE equals mgh, or potential energy equals mass times gravity times height. In order to better understand the relationship between kinetic and potential energy, watch this demonstration of Rocky lifting some dumbbells.
As the height of the dumbbells increases, the kinetic energy decreases while the potential energy increases. Once Rocky's arms are outstretched to the maximum length, there is 0 kinetic energy and the maximum potential energy is reached.
Thermal energy is the sum of atom and molecule kinetic energy in a substance and the elastic potential energy stored in bonds between atoms. The hotter an object is, the more the molecules vibrate, which in turn causes more kinetic and elastic potential energy. The colder an object is, the slower the molecules vibrate, which in turn causes less kinetic and elastic potential energy.
Power is defined as the rate of energy transformation or transition and is kept track of via its unit, the watt. Power is essentially the amount of work done in a specific time interval, or for a shorter, more formulaic approach, power equals work divided by time. We can compare power to something like frequency, revolutions per second, to understand its purpose better. Another way to explain it is that when a force transfers energy through work, that it is the power of that specific force. For example, an engine is exerting a 2,000 Newton combined force on all 4 wheels of a car. This car travels 30 meters in 5 seconds before the engine shuts off. What is the power of the engine on 1 wheel? So let's go write this out on the board.
Alright, so for this problem, we're trying to find the force of the engine on 1 wheel. We have the total force of 2,000 newtons, the time is 5 seconds, and the displacement is 30 meters for our givens, right? So first of all, first step, divide 2,000 by 4 to get 500 newtons. You might be asking, why would we divide that by 4? Because we have 4 wheels and we're trying to just find the power on 1 wheel. Second step, work equals force times displacement. We have the force, which is now we transferred to 500 newtons because we divided it by 4. And now we have our displacement in our given 30 meters.
500 times 30 is 15,000 joules of work. Now, third step is going to be to find the power itself, which is going to be work divided by time, 15,000, the joules we discovered earlier in work, divided by time, 5 seconds, equals 3,000 watts of power.